Hi, this is N5.6, Understanding Decimals to the Thousandths Place. So when you're working with decimals, you're going to see the ending of the place value words has THS. So there's tenths, hundredths, and then thousandths. Now the word thousandths doesn't really roll off your tongue because that THS is kind of hard to say. But just remember that this is different from tens, which would be TENS, and hundreds and thousands. So just be careful how you're saying them. So in a decimal number, we are only going to be talking about decimals with 3 place values. Okay, so if I said decimal 135 or 0.135, there's your tenths, there's your hundredths, and there's your thousandths. So the decimals that we're looking at in this outcome have 3 digits. All right, so we need to be able to describe and represent, relate them to fractions, and put them in order and compare them to each other. So remember that decimals are, just like a fraction, part of a whole. You got it. Okay, so decimals aren't showing a whole number. They are showing a fraction of a number or a part of a number, a small chunk. Okay, so we've just told that story. You can tell me orally that decimals are a part of a whole, and you can draw a picture of something that is a whole section and then a part of it to show that it's a decimal. You can represent decimals in many different ways, and I've got a few slides coming up that show you just that. We've talked about why decimals are important to ourself, our family, or community. One of the biggest reasons, money is all in decimals. Recognize and generate equivalent forms. So being able to take a decimal and turn it into a fraction that means the exact same amount. Demonstrate using concrete or pictorial models to explain how a quantity in tenths, so that's our first place value, or hundredths, that's the second place value, can also be recorded as hundredths and thousands. So all this is saying is that decimal 2 or 0.2 can be written as 0.200 or 0.20000. Putting zeros on the end of the decimal does not change anything. So if I give you a decimal like this, decimal 45, and I say write an equivalent decimal, something that means exactly the same as decimal 45. Well, you could put a 0 in the ones column because there are no ones. You have to keep your 4 and the 5 the same, but you could put a 0 in the thousandths column because there are no thousandths, and those two numbers are exactly the same. You could write it again with more zeros on the front of it, or more zeros on the end of it. You could go on forever with those zeros. It does not change the amount. Describe the quantity represented by each digit. So we're going to be talking about place value. Test the equality. Decide if decimals are equal, like the example that they've given here. Is 0.7 equal to 7 over 10? And we'll get into that in just a minute. Use and explain personal strategies for writing decimals as fractions. So being able to convert one to the other, back and forth, they are both representing, again, part of a whole. So if I have a whole pizza and I cut it up, I can say that I ate 0.5 of the pizza, or I can say that I ate half of the pizza. They both mean the same thing. And writing fractions with the denominator of 10, 100, or 1,000 as a decimal, and that is exactly the same thing that we just talked about, and I will show you some examples coming up. Identify benchmarks on a number line. Now we've talked about important fraction benchmarks, and you can also have decimal benchmarks, same thing, that could be used to order a given set of decimals. So putting them in order, biggest to smallest, or smallest to biggest. Using benchmarks to order decimals relevant to your life. Okay, let's have a look at some of those examples. Ta-da! The world of decimals. Okay, so here we have, look up in the very top corner. These are the judges up here. And they're holding up scorecards. And so this would be a real life example of where decimals are used, deciding the difference between scores. Looks like 2 people scored a 5.5 and the Russian judge gave her a 10. All right, let's have a look at the meat. The meat is pretty interesting, and you will see this from time to time in the store. Do you think that this steak price is correct? This is one piece of steak that you would buy at Safeway or whatever. Okay. The unit price is listed as $10, roughly, $9.9 per pound. So think of a pound as one of those big blocks of butter. That's a pound. So it would be reasonable to assume that maybe some meat is worth that much. So I'm not sure where the problem came into play here, but it's telling us that this steak is $1,049. Now, I don't think I would pay $1,000 for a steak. I think what they meant to say is this decimal in the $9.99 was supposed to go over there somewhere. And what should have happened is this should be a $10 steak, $10.49. So you'll have to watch in stores. Sometimes that does happen. You might get a deal. You also might pay $1,000 for a steak. So it's really important to know your decimals. So we can see the example on the stopwatch over here. The swimmer had a time of 39 seconds. And then there's this 0.82. Now, stopwatches don't often show decimals. This would be the hours. This would be the seconds. And this would be fractions of a second or parts of a second. Again, a decimal or a fraction is part of a whole. So what this is showing is part of a whole second. So 0.82 of a second is almost a full second. And let's have a look down in the bottom left at the gas station prices. Gasoline is always advertised on the billboard out front how much it is per gallon or per liter. And so this is saying it's $1.35 per liter, $1.75 for the plus gas, which is a little better quality, and then premium gasoline, which is the best quality, is $2.01 per gallon. So you need to be able to do some quick math, and this is important to watch when you become a driver because quite often gas prices will jump up or go on sale. And a lot of the times you don't even realize, you just fill up your tank and pay the money and don't worry about it. But if you actually shop around for gas, you can save quite a bit of money. All right, let's have a look at the Famous Mart. Now, I don't know what they're famous for, but I would not pay $999 for a blanket that was regularly $89. So obviously somebody didn't have a good understanding of decimals, whoever made this sign, or they just got lazy and didn't put them in. But I think what they were trying to say is that these Eddie Bauer blankets were regularly $89. Now in a number like 89, where's the decimal? So we talk about the understood decimal. It's just understood. They didn't put it in there, but we know that 89 is the same as $89 and no cents, right? So there's that understood decimal right there. It always comes at on the right side of the number. So there is no decimal in their sign, but it's understood that it's at the end of the number. So then where is the decimal in the bottom numbers? Well, if we're using that concept of the understood decimal and we put it at the end, just like we did with our 89, well, now we have $1,499, so $1,499.00. So that is not a deal, Famous Mart. I think they just forgot to put their decimal place in. What they really meant to say is that these blankets are on sale for $9.99, going up to $14.99, which is a good deal. Okay, the last section to look at is the books. We use decimals in a library in a system. I don't know if I can write it in here. I'll try it with black, we'll make it thick. Called the Dewey Decimal System. Now, Dewey, he was the guy that invented this categorization system. He must have been a librarian, and he had all these books to figure out where to put, and he developed this system. So he has sections in the library, and you can ask our librarian about this, but each book has a certain topic, of course, and so this looks like it's something to do with the scrapbooks. Okay, recording memories, journals, looking at scrapbooks. And it must be in the 700s because all of these numbers are 745 point something. So then you have a look at your authors and you can see that they go in alphabetical order. So we have G, H, I, J, K, L, M, N, O, P, Q, R, S, and on and on and on. And the rest of these are S's, W's at the end. So you'll see going from left to right, the author's name goes in alphabetical order. But then you also have the rest of the decimal number. So they must have said that the 745s, okay, so this is the 745 section. All these scrapbook books are in the 745s. But when you get a new book that comes in and you want to put it, say, between this white book and this orange book because maybe the author's name fits in between there, how do you figure out the numbers? That's actually not a good example because you can't see the numbers. Let's put it between these two books. So we have 745.5938 right there. And then we have 745.5938. Well, these are both the same author, that's why. All right. If you wanted to put a book in between there, you could, and you could give it its own decimal number by simply adding a digit on the end. So 745.59381. Actually, we'd have to give it to this side. Yes, not this side. Okay, because technically this is a 0 right there. Okay, so you can always fit books in between. You can always find a decimal number that goes in between two other decimal numbers. So there's a ton of real-life examples where decimals are used. Okay, so how do we represent decimals? Well, you could do it on a number line. Now, forget about this number line. I'm not sure why I have that in there, but the first number line, you can see that it goes from 0 to 1. Actually goes from 0 all the way to 20 down at the end. But in between those numbers, we could chop it up into 10 pieces, and each one of those pieces shows a tenth, or point something. Okay, so if I put a red dot right here, where would you say that is on the number line? Well, it's not on the 7 and it's not on the 8, it's in between. So you could take a guess and say, well, if I chopped that section up into 10 pieces like they did with those other ones, the 5th piece would be right in the middle. Really hard to draw with this pen, but you can see that my original red dot would be at about 7.2, somewhere in there. Okay, and if I put a magnifying glass on that section between 7 and 8, we'll just redraw it over here. And remember I said the 0.5 is right there, 7.5. So this might be 7.1, 7.2, 7.3, 7.4. That was 7.5, 7.6, 7.7, 7.8, 7.9. And then instead of saying 7.10, we know when our 10 is filled that we make a whole number, and so we're up to 8. Okay, so if we said this spot right here is 7.2, Could I find a number between 7.2 and 7.3 in this little section here? Sure, I could split that up into 10 pieces and say, well, 7.25 or 7.21 or 7.27, or all those numbers go in between there. So you can always chop up a number line and show a decimal and its representation using a number line. You could also show a decimal down here using a Dave. So they're just simply dividing, and they're showing that this fraction, 3/7, remember a fraction bar means divide. So it's 3 getting divided by 7. And we talk about the little trick to remember how to write a fraction into a Dave. Your bottom, your big fat bottom, sticks out, and so it's outside of the Dave. So remember that your bottom sticks out. Okay, so when you write your Dave, you have 7 and you have your 3 on the inside. Does 7 fit into 3? No, it does not, and that is why our first digit is a 0. Now 3, the understood decimal, remember we just talked about that. If I have a number 3, where is the decimal? I didn't write it in yet, but where would the decimal go? Where is that understood decimal? Well, remember it's right after all the digits. It's on the right-hand side of the number. So they've written 3.0 inside, or 3.0 inside the Dave. And then they can say, well, does 7 fit into 30? Yes, and it goes 4 times, that's 28. They subtracted, right? Oops, right there. They got a 2, they brought down the 0. 7 fits into 20 twice. And so they put their 2 up there. I'm now going to change colors. Okay. They subtracted 0, take away 4, you can't do, but 20 take away 14 is 6. Then they brought down another 0. You can bring down zeros all day long in this particular question. Okay, so 3.0 is what they started with, but what they really have is that happening, right? 3.00000, which means exactly the same thing as 3. Exactly the same. So when you're finding the decimal representation of a fraction like 3/7, remember that your bottom sticks out, rewrite it into a Dave, and then do your division. And wherever your decimal is inside the Dave, there's that green dot right there, 3.0, is where the decimal is going to go in the answer, right above it. Okay? So you can also represent a fraction up here in the top corner by drawing a picture. So they've shown that this yellow section of the circle is 1/4 or 1/4. They've put it in as a decimal, saying that's the same as 0.25. Think about money, right? And they've also said, well, that looks like 25%. So decimals, fractions, and percents are all different ways to write the same number, and they are all part of a whole. Okay. The last way that I have down at the bottom here to show a decimal, you could use a place value chart. So when you're working with decimals, you pick what works for you. You can show it on a number line, you can draw a picture, you can show it with an equation using a Dave, you can show it on a place value chart. Lots of different ways to show what a decimal means. So the 15 in this case is the whole number, and then this 4759, that is the decimal part. And they're saying that the 4 is in the tenths column, so that means 0.4. The 7 is in the hundredths column, so that means 0.07. The 5, look how everything's getting smaller and smaller and smaller as we go this way. The 5 is in the thousandths. It's just a tiny little dot right there. Okay. And because it's in the third place, we have 005, right? And the last digit is in that thousandths place. or sorry, in the 10,000s place. So you can show decimals on a place value chart if that suits you. On to the next one. Okay, the last way that you can show a decimal is using base 10 blocks. Now this gets a little tricky because your whole life, when you worked with whole numbers back when you were little, these meant different things. These little guys at the end, those were the ones, right? But now when we're working with decimals, we can let them represent whatever we want, right? And so when we're working with decimals, we now say that these blocks, those flat plates, are the ones. And so when you have this guy over here, that's one of those flat plates. This is now a 1. Is the whole thing shaded in purple? Nope, only part of it is. So a decimal shows part of this. Well, how much is shaded? Well, they've said 1/10 of it is shaded, which means 0.1, which also means 10%. Okay, let's look at the orange example. So if we're thinking about base 10 blocks in this new way that we've just talked about, where these guys are the new ones, this diagram is showing that there are 2 of them. So we have 2 as the whole number. How many tenths do we have? Well, we have 6 of them. So we have 2.6, or 2 and 6 over 10, 2 and 6 tenths. You could also represent a fraction or a decimal with writing out the number, 2 and 6 tenths. So lots of different ways to represent a decimal. Okay, let's look at that last orange example. How many whole plates do we have? Right there. So there's 1. How many tenths do we have? Looks like there's 4. Don't forget to put that decimal there, because there's not 4 ones, there's 4 tenths, right? And how many hundredths do we have? Right on, there's 3 of them. So that means 3 over 100. Okay. How would you write this as a fraction? Well, let's look at this number all together, 43. So you have 1 whole and 43 over, what do you think? Should we use 10 or should we use 100? Well, since we have 2 decimal places, we need to have 2 zeros in the answer, in the denominator. Okay? All right, so this just shows the same thing, except this is a bit more mathy without all the diagrams. When you have a fraction, you could simply type that into your calculator, 2 divided by 5, and it would give you this, 0.4. What that actually means is the 4 is in the tenths place, so that means that it's 4 over 10. Okay. This also means, if you got that on a test, your mother would not be impressed, 40%. If you got 2 out of 5 right, that's less than half of them, right? So that makes sense that it's 40%. Okay. If you got 3 out of 50 on a test, oh my gosh, that'd be bad. That means you didn't even get 6%. 6 out of 100. So they've written this 3 over 50 as a reduced, or sorry, they've doubled it to get 6 out of 100. So these are all just equivalent ways to write the same number. 6 over 25, they've multiplied by 4. What you do to the bottom, you must do to the top. Same thing here. Okay, so they're putting all of these into denominators of 10, 100, or 1000. Okay, so what did they multiply the 4 by to get 100? Well, Must have been 25. What you do to the bottom, you must do to the top. Fraction Police says so. Okay. Then if you type this into your calculator, you would get 1.25, which is greater than 100%. It's 125%. Okay. If you typed 7 divided by 250 in your calculator, it would show you this decimal. And remember what we said in the previous slides, if you've got 1, 2, 3 decimal places, that means you have to have 3 zeros in your answer. So 0.028 is the same as 28 over 1,000. This is the tenths, this is the hundreds, this is the thousands. Okay, good luck with decimals.